In this video, we'll build a simple web interface to our application for viewing the current state of our pumps. We'll also add functionality to the existing application so we can display the device's indoor location to assist a technician on site. We'll start by modifying our Lookups type. In the project resource graph, I'll click on Lookups. This brings up a dialog that displays all the properties in our Lookups table. We're going to add indoor location to this type, so we'll click on the Edit icon, which opens up the editor for types. Types in VANTIQ allow us to persist data into the platform. I'll click the Add Properties button, set the name to Indoor Location, and set the type to GeoJSON, and we'll save the modification to our Lookups type. Recalling from the first video that we placed the enriched data into our pumps type, we'll add the same property to our pumps type. We'll click the pumps type in the resource graph, edit it, and add indoor location to it. I've modified the Lookups record with the following information representing the pump's indoor location. But when we compare that to the pumps table, we see the indoor location has not been set. We'll add functionality to our app that will place this data in the pumps type when the temp and RPM streams are correlated. All that needs to be done to accomplish this is to modify our transform data activity. I'll click on Transform Data and edit its configuration. I'll add an outbound property called Indoor Location and set the transform expression to event.enrichData.lookups.indoorLocation. Once we save the application, the data will instantly start propagating to the pumps table each time the data is correlated. Now, let's build the client web pages. In VANTIQ, I'll choose Develop Clients, and then click New Client. I'll open the client's properties and give it the name Pump App, and mark it Launchable, which means that it will be exposed externally. Now we want to display some information about all the pumps, so we'll add a table widget. To bind data to the table, we'll need a data stream, so I'll click on Data Streams and then New Data Stream. I'll name the stream Pump Stream. There are several ways we can receive data: directly, as information arrives, from a source, like MQTT, but in this case, we'll use a timed query, which will grab the latest version of the data at a specified interval. For the data type, I'll choose Pumps and set the update interval to every 6 seconds, and we'll group by the pump ID and save the work. Now, we'll bind it to our table by clicking on the table and choosing our pump stream. For columns, we'll set the pump ID, the time it arrived, the temperature, and the RPMs. And I'll adjust the table with a drop by dragging so as to take up more of the screen real estate. Let's test our app by running our client. Here we see all the data we've asked for in the table. Now let's add some graphs to help quickly visualize potential issues. I'll drag a horizontal layout control widget onto the canvas, and in it, I'll place a column chart, and just to its right, a bar chart. I'll click on the column chart and pick the pump stream for the data stream. On the x-axis, we'll choose the pump ID, and on the y, RPMs. We'll also set a threshold value of 4,251. In our bar chart, we'll also choose the pump stream. For the x-axis, we'll choose temp. For the y, we'll choose pump ID, and for the threshold, 199. When we run our client application, it now appears like this. We'll add an onSelect function to our table, which will have a single line in it, client.goToPage, with the parameters for the page that we want to go to. The page name is pump detail, which we haven't created yet. And the data that we will pass to the page is an out-of-the-box variable called extra, which is all of the data from our query for the selected row. Let's add the second page to our application, so when we click on a row in our table, it will take us to the pump detail page that we specified in the onSelect. So we give it that name, pump detail. We'll also set an onPage start function, which will modify our data stream to just contain information about an individual pump. So we'll get the data stream using its name, pump stream, Specify a new query that constrains the query to the pump ID that was passed into the page when the user clicked on the table, and then call for the data stream to be immediately updated. Now, to visualize all of this, I'll add vertical and horizontal layouts to the canvas. In the vertical layout, I'll add 2 gauges, one for temp and one for RPMs. I'll also put text widgets above each of our gauges so we know what they are. We'll name the top one temp and the lower RPMs. We'll configure the top gauge using our data stream and set the property to temp. And we'll set some thresholds, a warning at 150, danger at 199, and a gauge maximum of 250. For the bottom gauge, we'll use our data stream and set the property to RPMs. We'll also set thresholds here as well, a warning at 3,500, danger at 4,250, and a gauge maximum of 5,500. Now, we'll populate the horizontal layout object with the external and indoor locations. For this, we'll drag on a map widget and a floor plan. We'll configure the map with our data stream, and for the property, we'll use the location object, and for the label, the pump ID. For our indoor floor plan, we'll set the data stream and choose the indoor location for property. For the label, we'll choose the pump ID, and for the floor plan URL, we'll use a VANTIQ document that can only be seen with the proper credentials. A few quick cosmetic adjustments to the size of our objects, and we're done. We have modified our existing application with new data to enrich the event stream. We've created a web client that can now be accessed with a valid username and login, and we can see the table with each of our pump IDs and the overall detail for our pumps in the graphs on screen. By clicking on a row in the table, we can drill down onto an item and see additional details about the specific pump that was chosen. Thanks for taking the time to watch this video series on VANTIQ, the application platform for building event-driven systems. To see more videos or learn more about VANTIQ, visit us at vantiq.com.